So this is a typical 1930s power supply that was used in pre-war pinball machines, gambling machines, things like that. This is pretty typical. There were different manufacturers. This one says Mills, although it was really made by Electrical Products in Detroit. There's a couple other companies that made them, but their construction is pretty much all the same. You have a transformer right here, which converts 110 AC to a lower voltage AC, and then usually there's just one of these. It's a selenium rectifier, and that is what converts the AC to DC. This one has two. I'm not exactly sure why, but I will find out. And this one is rated for 12 volts DC. They also put out AC, although it didn't say it on the cycle, on the label, for the lights. So the DC was typically used for the coils, the AC for the lights. And you can see right here, this is how they label it. The two terminals for DC are here, two terminals for the lights, which was AC. This was typically about 6 to 8 volts AC. DC varied. This one is 12 volts. And it's pretty simple. The power came into the transformer up here, and then it was stepped down to two or more lower voltages. This one, these two leads go to the AC, so that would be the 6 to 8 volts DC, AC, sorry. And then the other AC voltage came and went to the rectifiers, which then converted it to DC, and that was put out on this this terminal here. They typically use the chassis as one of the conductors, and so the rectifiers were mounted to the chassis, and it's actually an electrical connection the way they worked. And I won't go into that in great detail. You can look it up on the internet. But basically, you applied AC to these things at two different terminals, and they produced DC. And the problem with the selenium rectifiers is they were not very stable, especially with time, and they would break down, and they would start to leak electrically, and they would get hot, and eventually they would just break down. Sometimes they would catch fire and of course become no good. So what I'm going to do is replace these functionally with a modern rectifier. I'm going to leave these on here, probably clean them up just for effect, even though they won't be functional. And then this thing will be good to use for anything that needs 12 volts, and also for the light circuit. So the first thing I'm going to do is disconnect these wires here from the transformer to the rectifiers, and then I'm going to plug in the transformer. You never want to plug these things in without doing this, because if the rectifiers are bad, they could literally catch on fire. So these are some pretty heavy-duty connections. So what I'm going to do is just cut them for the time being, since we're not going to use the rectifiers anyway. There's two leads coming from the transformer. Here's the other two. And I'll probably leave the AC light ones connected for now. Okay, I've got the leads stripped and connected with jumpers. I've got this is 110 coming in here. I always use a fuse inline. This is a 10 amp fuse. Just in case, if you short some wires together, it could be nasty if you, but these fuses blow pretty quick and eliminate a lot of the damage. The red and black 110 goes to the input of the transformer. The output are these two leads here, and then these two, I'm going to measure the voltage on them. I've got my meter connected to the yellow and green jumpers. So I'm going to turn the power on, and you can see, okay, we've got 20 volts coming out of that pair of leads, which is one of the output windings in the transformer. I'm going to switch it over to the other one. I can do this. And we got 20 volts coming out of that too. So what I think they've done is the transformer has two output windings, each 120 volts. And I think they just ran them in parallel to the selenium rectifiers and rectified it. So you basically have two 12-volt DC outputs wired in parallel, which gives you more power, more amperage, basically. I'm not sure exactly why they did that. You could have gotten just a bigger transformer with more power and one rectifier, but maybe it was a size issue, a packaging issue, because they would have been physically bigger. But anyway, that's what I believe is going on. So I'm going to figure out how much power I need to get out of this and wire in some rectifiers. The AC voltage, which I can connect here, or the AC light voltage, I should say, is 6.5 volts. So that's the light circuit that we were talking about, and that's AC. It's not rectified, and it just goes straight out to the lights of the machine.